Transformations of parent functions. In this lesson, you'll be able to describe the transformation of a graph by using the values in the equation only. The three transformations that we'll be discussing are reflection, dilation, and translation. Before we start looking at equations, let's take a look at some graphs. You'll notice here I have on my graph y equals x squared. This is a parent function, a function that has no constants or coefficients and is in its simplest form. Underneath it here, I'm going to write another function, the same as what I have above, y equals x squared, but I'm going to modify it somehow. I'm going to add a constant here. Watch what happens when I add plus 3. This was my parent function. This is my new function. Y equals x squared. Y equals x squared plus 3. What if I type another function? Maybe this time I will put, instead of a plus 3, maybe I'll put a minus 4. Now I'm going to do it again. This time, I'll put a plus 1. Maybe this time, I'll put a plus 2. So let's take a look. Our parent function started here with its vertex at the origin. When I put a plus 1, or a plus 2, or a plus 3, what happens to that parabola? It's shifting up. Well, what if I put a minus 4? That shifted down. So it seems like when I put a constant here at the end, it takes my parabola and shifts it up or down. What if this time, instead of adding a 3 outside of the grouping symbol, I add it inside the grouping symbol? Let's see what happens. Plus 1. What if I put a plus 2? What if I put a plus 3? What if I put a plus 4? It seems to be shifting or translating to the left. What if I change all of these to minus signs? Minus 1. Minus 1, minus 2, minus 3. It seems like it's shifting to the right. So far we've tried putting constants outside of the parentheses. That shifted it up or down, right? We put some numbers inside the parentheses. That shifted it right or left. And all of these are called translations. Now, instead of adding a constant, what if this time we add a coefficient? Let's see. What if I times this function by 2? Or what if I times it by 3? Or what if I times it by 4? Do you see how this parabola is stretching or getting more narrow and narrow with every coefficient that I put? What if I put a 7, or an 8, or a 9, or a 10? This is known as a dilation. And it can, as long as the number is higher than 1, stretch vertically this parabola or make it more narrow. Now, in order for the parabola to go back to its parent function, you need to remove that coefficient. Now, you can have a coefficient that's lower than the number 1, like let's say 1/2, or 1/3, or 1/4, or 1/10. This is a compression, a flattening of the parabola, making it wider. Now you'll notice these are fractional, but they're not lower than 0. So when you have a coefficient that's higher than 1, you are stretched vertically by that factor. So this one here in orange is widened or stretched by a factor of 1/2. This one here is more narrow or stretched vertically by a factor of 4. Now if I were to take these coefficients away and put a negative sign here, let's take a look and see what happens. It looks like it reflects. So the negative sign reflects over the x-axis. The coefficient makes it a different size, and the constant shifts it up or down, or left or right. Let's review what we just saw on the graph. The placement of the numbers creates a different transformation. So any function, no matter what its grouping symbols, whether it's a square grouping symbol or absolute value bars or even a square root sign, the placement of these three numbers, a, h, and k, all do something different. If a happens to be negative, that is something different as well. Let's take a look at a few examples. Pause the video and try writing the description of the transformation that occurred in these two functions. Don't forget that when you have a constant after the x squared or after the grouping symbol here, that constant moves an item up or down. So according to function g in number 1, plus 4 is a shift or move or slide 4 units up. And number 2 is a shift, a move, a slide, or a translation 7 units down. Let's take a look at some more examples. Pause the video and try describing these transformations. All right. Notice that these constants are inside the grouping symbol. Any number inside the grouping symbol is a shift left or right. Now be careful with these signs inside the grouping symbol. They're a little counterintuitive because the formula has its own minus sign in it. So if you're moving to the left 3 units, minus 3, then you would have a minus 3. And that's why the formula would show a plus sign. So movements to the left, see that there? Movements to the left have a plus sign. Let's take a look at 2 more that have multiple shifts. Example number 1 has 2 different translations. This plus 2 and this plus 3 mean different things. The plus 2 means a shift 2 units left. And the plus 3 means you are shifting 3 units up. In question number 2, the minus 4 inside the grouping symbol means that you shifted or translated 4 units to the right. And the 7 means you shift, move, slide, translate 7 units down. Now let's take a look at some dilations and reflections. Here's our parent function f of x. Here's an example of a transformed function, so we give it a new name, g of x. And you'll notice it has an additional number in it. And this time, the number is a coefficient. And if you're a coefficient, then you perform a dilation. That's either a stretching, if the number in the a position here is greater than 1, or a compressing if the coefficient is between 0 and 1. This one here is stretched by a factor of 6. That means it will be more narrow. If this is the original parabola, a dilation of 6 will make the parabola stretched and more narrow. Now, if I took that 6 and made it negative, the parabola would be reflected. So that means 2 transformations would occur. The negative sign does one transformation, but the 6 does another. Let's take a look at our graph again. If I have the graph of x squared, and then I type 6x squared, by placing that coefficient out front, you'll notice that it gets more narrow. But then, if I put a negative 6, you'll notice that it flips upside down. So that's 2 transformations. The negative sign has nothing to do with dilation. The 6 is the dilation. The negative sign is the reflection. All right, let's put it all together now. Can you describe all of the transformations that took place in these functions? Pause the video and write them down. For function number 4, 3 things occurred: timesing by 1/3, subtracting by 1 in the grouping symbol, and adding 2 outside the grouping symbol. That's 3 different transformations. In example number 5, 4 transformations occurred. The negative sign is a reflection, the 3 is a dilation, the 4 is a translation, and the 7 is also a translation. Let's see if you got all the vocabulary words correct. Take a look at these answers. The first one, 1/3, is a fraction, so that means it compresses vertically, right? It gets wider. Compress vertically by a factor of 1/3. The 1 is a shift to the right, and the 2 is a shift up. For question number 5, the negative is a reflection over the x-axis. That's its own transformation. The 3 is a dilation, a stretching vertically by a factor of 3. The 4 is a transformation of translation, or shifting 4 units left and 7 units down. So don't forget to look carefully at where the placement of the numbers are in the grouping symbols. That will tell you how a function is transformed.